Imagine you walk into a restaurant and you sit down and you look at the menu and you call the waiter and you say, "Yeah, give one biryani, please." Then the waiter walk into the kitchen, give the order to the chef, and the chef cook it, and the 20 minutes later, your biryani arrives. So this is actually the client server model is. This is how the entire internet work. And once you understand this analogy fully, and you will never be confused about how HTTP, REST API, or the web applications work. So hello guys, welcome to Deep Developer YouTube channel. So this is the day 2 of our system design series. So let's start with the video. Let me break down the restaurant analogy properly because every part of it mapped to something real in the tech. So first, the customer is the client, the person who wants something, so who initially initiate the request. In the real world, this is your browsers, your mobile app, or even your own Java code calling to another services. Then the waiter is the network. The waiter does not cook anything, it just carries your request to the kitchen and bring the food back. In the tech, HTTP is the waiter. It carries your request from client to the server and bring the response back. And the kitchen is the server. This is where the actual work happens in our world, in our Spring Boot applications that is running on our locally 8080. So this is actually the kitchens. So it receives the order, process it, and send back the results. Then the menu here is the API. It defines what you can order. You cannot ask something that is not on the menu. Similarly, you cannot call an endpoint that does not exist on the server. Then, and the next is our food that arrives. So this is the response. In the tag, it usually a JSON object with the data you requested. Technically, what is client? The client is any software that sends a request to the server, and that is the complete definitions. So let me show you the three types of client that you already know. First one is the browsers. When you open in Chrome and type google.com, the Chrome sends the HTTP GET request to the Google server, and the Chrome is here the client. Then secondly, a mobile app. When you tap order now on the Swiggy app and it sends the HTTP post request to the Swiggy's backend, then the Swiggy app on your phone is here the client. Third one is, this is one which surprised most Java developer. Your code, your own code can be a client. So think about microservices. You have an order service and it's a need to call the payment service. So when the order service makes the call using REST templates or the web client, the order service is here acting as a client. It is sending a request to the another server, which we can take as a payment service, which is act as a server. So the key insight is this is a client that does not have to be a human users. Any software that initiate the request, that is a client. This will matter a lot when we reach the microservices topic in the phase 3. Now on the other side, what is a server? So server is any software that listens for a request and sends back the response. Here is the keyword listens, means a server is running 24 hours a day, 7 days a week, or 365 days, waiting for someone to send it a request. When the request arrives, it processes it and send the response. Now look at the Spring Boot code on the screen. It is a basic order controller. So here the annotations, the REST controller, this is what tells the Spring Boot that the class is a server. It is saying listen for HTTP request in the path, and when one arrives, run the methods and sends back the response. So when you run your Spring Boot applications, it says like Tomcat started on the port 8080. So your application has just become a server now. it is listening on the port 880 for the client to send any request. The three things every server does by default is: 1. It always listening, it does not sleep, it runs until you stop it. Second, one server can handle thousands of clients simultaneously. You do not need to have one server per user because it is like not an useful. Then third one is HTTP is a stateless. This means the server has no memory. Every request is treated as a brand new request. The server does not remember your previous request. So last point about the statelessness is something that trip up a lot to the Java developer, and it is up in every single system design interview. So we will go deeper on this when we will be learning the sessions and tokens in our upcoming videos. Okay, now let us put it together, like what actually happens when you type an URL on your browsers and the press enter. So there is exactly this 6 step will be happening internally. So this step 1, you type an URL, your browser receives the URL and knows it need to find the server that has that addresses. Next is the DNS lookup. Your computer does not know what IP address google.com map to, so it asks the DNS server, basically the phone book of the internet, to look up this particular google.com mapping. So DNS return the IP address something like 142 dot something dot something dot something something like in the digit format. And the step 3 is that TCP connections. Before any data is sent, your browsers and the server do the three-way handshake to establish the reliable connections. The thinking of it like saying hello or to the sync act. So we'll cover all these details in our day 6 video. Then step 4 is that HTTP request is sent. Now your browser send the actual request, something like get slash search slash, if you're searching system design, so q equal to system design, and with HTTP slash 1.1 with the versions, and this travel over the TCP connections to the server. So step 5 is server process the request, receive the request, runs your code. In our case it is the Spring Boot handles it, maybe like querying a database and prepare a response. Then step 6 is that response is returned. The server sends back the response with a status code like 200 and OK with the data, usually in the JSON format, and your browser receive that and render the pages. So this cycle, this 6 step happens billions of times per second across the internet. So every API call you make from your Java code goes through some versions of this particular 6 cycle. Let us talk about HTTP method, the vocabulary of the web. So when a client sends a request to the server, it has to say what it want to do. So that is what HTTP methods are. So in the Spring Boot, which we are taking as an examples, so there are actually 4 main ones, and as a Spring Boot developer you already are using all of them. So first one is that get. This is for reading the data. When you call the get mapping in the Spring Boot, you says when someone sends a get request to this URL, run these methods and no body in the request, just fetch and return the data. Next is that post. This is for creating a new data. We will be using other post mapping, and this client sends a JSON body in the request with a new data to create. So we use a request body to read the in the Spring Boot. Put, this is for updating the existing data. So put mapping we are using, and usually includes an ID in the URL to identify what to update, and the body with a new value. Then the delete is for delete mapping is for the deleting the data. So we'll be using other delete mapping, and usually it's just the ID in the URL, no body needed. So one important things to understand in this concept is like idempotency. So like get, post and delete are idempotent. Calling them multiple times gives the same result. And post is not the idempotent. Calling it twice will create the two records. So this matters a lot in the system designs when we will talk about retries and the distributed systems. Let me give you the 4 client server questions that come up most in real system design interview, and this is how you should answer them. Question 1: what happens when you type google.com in your browser? This is the most commonly entry level system design questions. Your answer should be like DNS lookup to get the IP, TCP for handshake, HTTP get request is sent, then server process and response, then the browser render. These are the 5 steps. You should remember them. The questions 2 is what is the difference between HTTP and HTTPS? HTTP sends the data in the plain text, and HTTPS adds TLS encryption so that data is encrypted in transit. Always use HTTP in the productions, never send password or the token over the plain HTTP. Next question is that what is stateless versus stateful? The HTTP is then stateless. The server does not remember you between the request. To maintain the state, like keeping you logged in, we use sessions stored server side or use JWT token sends over every request. And the fourth question is that how does client and server scale? This is the bridge to load balancer, which we cover in the phase 2. The answer is simple, like multiple server instances run behind a load balancer. So client sends request to the load balancer, which routes them to the available server. The client does not know or the care like which server is responding. Now let me summarize the day 2 in this 4 point. So first one is always initiate. The server do not push data unless asked in the standard HTTP. The second, your Spring Boot app with other REST controller is literally a server listening for the request. And third is the HTTP is testless. Every request is idempotent. The server has zero memory. And the fourth is client are everywhere. Your browser, your app, even your own microservices. Tomorrow on day 3 we will go one layer deeper. IP addresses, DNS and the port. So how does your request actually finds the right server out of billions of on the internet? So this concept we will be learning tomorrow in more details. So if this video finds you helpful, please hit the subscribe button so you will not miss the day 3 video. Drop a comment below what is one things from the 2 day that surprise you. See you tomorrow. Thanks for watching the video.